Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to start the IUPAC nomenclature of the rules of the IUPAC nomenclature for the benzene derivatives. So let us talk about that. So benzene derivative can be a monosubstituted, can be disubstituted, or can be trisubstituted. So now we are going to talk about especially for that is the monosubstituted derivative, and then we'll move on to the next one. So talking about the first one, that is how can we name it by using the IUPAC rules of the nomenclature for the derivatives of benzene. So let us talk about that. That is for the first one. That is, the IUPAC name for the monosubstituted benzene derivative is obtained by placing the name of the substituent as a prefix to the benzene. So this is what I am going to talk about. So starting with an example. So benzene is the one that has been an aromatic compound that we know, or we could write it in this form. But talking about the derivative, so the derivative would be we could replace one hydrogen of the benzene by another group or by another atom. So that would be called as the monosubstituted, because benzene consists of basically 6 hydrogens. But when it comes to the derivative of the hydrogen, and when we are especially talking about the mono derivative of the benzene, then one hydrogen is being replaced by some another group, and that another group can be suppose like Cl, Br, anything like OH or an aldehyde group. So suppose in this case, if I have taken a atom like chlorine, so therefore this would be called as the chlorine derivative of benzene. But what would be the name of this one? So as we could see that only the chlorine atom that has been present, and that is the reason that the chloro, that is the prefix, would be used in terms of the IUPAC nomenclature. So therefore the name of this would be chlorobenzene. So therefore this is only the aromatic compound that consists of only one benzene ring, and it consists of a chloro group that has been attached, and that is because of which it is a derivative of an benzene, monosubstituted benzene. So that is the thing that we could call it as chlorobenzene. But the position of the chloro would be basically, it would be considered to be the position number 1. So therefore this is position number 1 that we can make. So therefore the name of this could be written as 1-chlorobenzene. So this is how we could give a nomenclature to a particular substance that has basically one benzene, and that is eventually a monosubstituted benzene. So this is how we could give the name for that. So this is the first rule that we have gone through, and for which we have got to know a very good information that we have to make the substituent as a prefix to the benzene. So now let us move on to the next one. And it is also for the monosubstituted derivative of benzene. So talking about the next one, that is, many of the monosubstituted benzene derivatives have common name that is accepted in IUPAC system. Yes. So suppose when we are talking about some of the common names, and even that common names are now being represented as the IUPAC names of that also. So for example, if I would say that is, so this is the benzene structure, and for which we are talking about a monosubstituted derivative. So suppose in this case, suppose if we have CH3. So this CH3, it has and a group, it has, and also it is having a benzene ring. This structure has a benzene ring. So therefore this could be called as 1-methyl benzene also. But this 1-methyl benzene can also, we could give a common name for that, and that common name has been accepted by the IUPAC nomenclature, and that's the reason the name of this could be called as toluene. And now moving towards the next one, there are few things that I'm going to talk about, and that is the thing that we would be able to give the IUPAC nomenclature to a structure that has been that would be provided to us. So now this is the toluene that we have, and suppose if another structure also, suppose if we have, which consists of a benzene ring along with that of a, that is NH2 group. So therefore this kind of the structure are being given as the IUPAC nomenclature as aniline. Talking about the another one, so this is a monosubstituted derivative of benzene in which it is OH group is been attached on the benzene ring. So therefore this could be also called as a hydroxy benzene, because OH groups are nothing but the hydroxy groups that are been they called, and now this could be called as hydroxy benzene. But the common name of this, it has been found to be phenol. So now phenol is the thing that we could also use as a suffix to a IUPAC nomenclature which consists of more than one substituents. So even that is phenol that can be used, and that is the reason that the common name is also basically the IUPAC name of this system of the structure. And talking about the another one that we have, so this is basically benzaldehyde. So these are basically the four, or there are many, but among this we have got to know that these are the four that are the common names also, and for which we could use these common names in the nomenclature of the IUPAC nomenclature for a particular structure. So this is what I want to tell, and let us talk about the next point that we have. That is this one. So it says that if the substituent is an alkyl group, and that alkyl group which is larger than the benzene ring, that is, it consists of 7 or more carbon atoms, then the compound is named as phenyl substituent alkane. So basically the compound would be said to be phenyl substituted alkane. For example, let me tell you. So let me tell you, that is, suppose this is a structure that we have and we have to name it. So in this case, what we could see that this consists of a group that is an alkane group, and in this case basically this is basically nothing but a benzene group that has been attached to this carbon atom, or this long chain of carbon atom. And in that case, for example, we could easily say that we have to set the longest chain according to the alkane, so therefore this would be considered to be the longest chain, or we could add more carbon atom over here like this one, suppose in this case. So this would be the longest chain of the carbon atoms. And talking about this thing, then this group, that is, now it is basically called to be C6H5, because the one hydrogen is been now replaced by such a larger group over here. So therefore this C6H5 is also, we called it as phenyl, and that phenyl is being attached to the carbon atom which is basically on the second carbon atom. That is, if I number it from here, therefore this one would be first, second, third, fourth, fifth, sixth, seventh, and 7 carbon atoms are over here, and that's the reason this whole phenyl group is attached on the second carbon atom, making this to be called as. And now this will be the parent name of this would be basically an alkane. So it is not the parent name would not end with a basically benzene, because it consists of more than carbon atoms, and that also they are arranged in a straight chain. So therefore the name of this would be 2-phenyl. And the total number of carbon in this case is basically 7, so therefore it would be called as basically 2-phenyl heptane. So this is what I wanted to mention. And talking about the another example that I wanted to talk about, that was, suppose if we have a group like this one. This is the benzene. Again, that benzene is been attached with suppose CH2. So now this kind of group, if we will observe, so therefore this kind of group that if we will observe in any kind of structure, then this kind of group are basically called as basically benzyl. So therefore this is the benzyl that we have. And suppose if any kind of functional group that has been attached towards this group, like this one, then this would be called as benzyl alcohol. So that is what I wanted to mention about. So let us talk about the another one that we have, that is, benzene ring is also concerned as a substituent when it is been attached to an alkane with a functional group. For example, suppose if we have a example like this one, that is, suppose this is a structure that we have and we have to give the nomenclature for this one. So therefore in this case what we could get to know, that is, because it consists of a substituent, that is, benzene consists of a substituent, and even the substituent consists of a functional group. So therefore the name of this would be basically, we would prefer that is the numbering from this carbon atom. So therefore this one would be the first, second and third. So that is what we have got to know over here. That is, benzene ring is considered to be the substituent when it is been attached to an alkane with a functional group. So this was an alkane that was been attached, but even the alkane is now been attached with this functional group. So therefore, now this benzene would be considered as a substituent of that alkane. Yes, so that is the reason the rules of IUPAC is very much important to learn about forex, especially for the derivatives of benzene. And now the name of this one would be, because as we know that there are basically two functional groups that are been attached on this alkane, that is a bromo, or the bromine atom is been attached over here, and a phenyl group is been also attached over here, because this could be called as also C6H5, which is basically known as phenyl. So therefore, the name of this one would be very much easy to give the name as, because according to the alphabetical order we have to give the number to give the name of that. So therefore, the bromo is the one that starts with an alphabetical order B, while the phenyl it starts with P. So therefore, the name of this one would be 1 bromo, and after that on third position it is phenyl. So therefore, 1 bromo, 3 phenyl. And the total number of carbon in a straight chain of an alkane in this case is basically 3, making this to be called as propane. That is 1 bromo, 3 phenyl. Propane is the IUPAC name for this structure, and that also consists of a benzene, which is nothing but a monosubstituted benzene. So this is what we have got to know. So this were all the rules of the monosubstituted benzene, and let us now talk about the disubstituted benzene. Even they have a specific rules for that. So let us learn about this one. That is, when it comes to a disubstituted benzene, then basically there are 3 possible isomers. So therefore, the isomers having the 2 substituents, that is in carbon number 1 and carbon number 2 position, carbon number 1 and carbon number 3 position, and carbon number 1 and carbon number 4 position. So this carbon number 1 and carbon number 2 position, suppose if a benzene is a and it consists of a 2 groups that are been attached to the benzene, or we could call it as a disubstituted benzene, then the position of the carbon number 1 and carbon number 2 is been called, and if both the substituents have been attached on, suppose the carbon number and carbon number 2, then that kind of groups in terms of a common name are named as basically ortho. And when it comes to the groups that are been attached on carbon number 1 and carbon number 3, then that is called to be meta in terms of a common name. And in terms of a common name, when the groups are been attached on the carbon number 1 and carbon number 4, it is called to be, that is para disubstituted benzene, or meta disubstituted or ortho disubstituted benzene. So this is the thing that we have to also concern about, that is on which position, that is on carbon number 1 or carbon number 2 or any position does the substituents are attached to. So now let us move on to the next one, that is or suppose for that we could also give an example like this one. That is for the first rule that we have for a disubstituted benzene. Suppose if the groups are been attached on this one, that is, if these are the 2 substituents that have been attached on the benzene, and we could say that it would, because we could concern anyone as the carbon number 1, so therefore in this case, because both the groups are been same, so therefore the group that has been attached, or the atom that has been attached to the benzene carbon atom, so therefore even this could be called as carbon number 1. But the next is we have to number in that form, because this is what we have learned in IUPAC nomenclature of alkane also. We have to number in that way that the another group should also get a less number. So therefore, if I number it from here, and if I am going in a, that is anti-clockwise, then this one would be 2, 3, 4 and 5. So this one would have got the 5th number. So that is not the correct method of the IUPAC nomenclature or the rules of giving the number to the carbon atom. So we have to always choose from that direction where we could get less number to the substrate. So suppose this is the first carbon atom and on which the chlorine atom is been attached. So the second carbon atom would not be this, but it would be this one. And this one would be the third, this one would be the 4th, 5th and 6th. And one thing we have to maintain and we should concern is that if the numbering starts from one direction, it cannot be reversed back to that direction. So that is the reason we have to always number from that direction where we could get the close number to the substituent atoms. So therefore the name of this one would be given as, because of the at position number 1 or at carbon number 1 chlorine atom is been present, and again on the position number 3 again a chlorine atom is been present. So therefore the name of this one could be written as 1, 3, di, because two are the same thing that are been attached over here. So therefore the name of this will be 1,3 dichlorobenzene. And talking about the common name for this one, because it are been attached, the groups are been attached at carbon number 1 and carbon number 3 in a benzene ring. So therefore the name of this could be called as meta dichlorovenzene. So even that is called, even they could call it in this way also. Therefore meta is the position, that is position number 1 and position number 3 where the substrates are being attached. So therefore even that could be called as meta chlorovenzene or meta dichlorovenzene. So now let us talk about the other one, that is that if both the substrates are the same, then the number of the substrates that are identical by the prefix di, and then the name of the substrate is been written. So that is what we have given the name to this one also, that is 1,3 dichlorobenzene is what we have mentioned over here. And we could also give another example like this one. Suppose a benzene is over here, and this consists of the two bromine groups that are been attached, or bromine atoms that have been attached to this benzene. Basically it is a disubstituted benzene. So therefore the number 1 will go to which bromine? We could give to anyone because it is the only bromine atoms that have been attached. So therefore this one could be given as bromine number 1. And yes, the numbering should not start from here. It should go with that direction where we could get less number of or where we could get less number to the groups that are been attached. So therefore this is the group number number 2 for this carbon atom, then 3, 4, 5, and it will go on. And that's the reason the name of this, because the two are the same groups that are been attached, or the same substrate that are been attached over here. So therefore the name of this one could be given as 1,2, because two bromine atoms have been attached over here. So therefore the name of this will be 1,2 dibromobenzene. So this is the rule that we have studied about. So even there are many rules, talking about the last rule of the second one, that is if the two substrates are different, it is named as the derivative of that special compound. Yes, suppose if the two groups are been different, or the two substrates are been different, so therefore we should give the name to that special compound. For example, if I am talking about this one, that is, this is the benzene that we have, and here it is NH2, and here suppose it is Cl. So now the numbering will start from which one? Obviously, because this NH2 is the one that we have did in the rule of the monosubstrate benzene, and in that we have got to know that the name of this is basically aniline. So therefore this one would be the first, second, and third carbon atom. So making this to be known as the chlorine, which is a chlorine atom that has been attached to the third carbon atom of the benzene. So therefore the name of this one would be 3-chloro, and the special name or the special compound in this case is basically aniline. So therefore making this to be called as 3-chloro-aniline. So this is what we have got to know. So till now we have discussed about the mono-substituted benzene, disubstituted benzene, and let us talk about the another one, that is, suppose what if the substituents are more than 2 substituents, that is, we are talking about 3 and 4. So in this case what will happen is the numbers are given such that it gives the lowest combination of numbers, that is locants, and that is what we have did earlier also. That is when we have talked about this as an example, we have given the number in such a manner that the lowest number should be received to the substituents, and that's the reason the numbering has started from a clockwise direction in this case, but it could be also anti-clockwise depending on the compound that we take or the compound that we have given, and that's the reason that we have numbered it from that form where we could get less number to the substituents, and that is what it has been written over here. And yes, the name of the substituents are entered in an alphabetical order. So we have to also indicate that the name that should be, we will express for a particular structure, that should be in an alphabetical order. Conclusion of the topic. So for example, I'll take an example like this one, that is, suppose it is the benzene that we have, and in this benzene, because multiple groups have been attached over here, so suppose in this case bromine atom has been attached over here, and in this case NO2, and again here it is also NO2. So the rule is clearly indicated that we should number in that form where we could get less number to the substituents, and so that is the case, and we should get a less number of combination. So for example, suppose if I number it from here or from anyone, suppose if I number it from this one, So therefore this is the one which will get a lower number, that is it would be carbon number 1, and then again on this would be carbon number 2, then this one would be carbon number 3, and then this one would be carbon number 4. So therefore the combination that we have got is 1, 3, 4. But what if I number it from here? So therefore this one could be 1, and suppose in any that is the direction, that is in clockwise or anti-clockwise I could give. So suppose if this is the considered to be the carbon number 1, so therefore this one would be considered as 1. So I have two options, clockwise or anti-clockwise. So I should go with that direction where I could get less number. So therefore this, suppose if this is the carbon number 2, 3, 4, 5. So this is the combination that we have got. And what if we have choose this as a carbon number 1? So therefore if this is the carbon number 1 that we have, so this is the carbon number 2, 3, and this one is 4. So basically among this thing that we have chosen, or that I have chosen, and in this case the least number, that combination that I have got is basically 1, 2, 4, making the numbering to be in such a manner that this one will be carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So in this case what you could observe is, because there are two such substituents that are being that are basically the same, that is the NO2 group, that are being same, or basically they are known as nitro group, and because the nitro groups are being same at position number 2 and position number 4, so therefore the word or the suffix, the prefix di would be appearing before the name nitro, and that's the thing that we could also observe, that the bromine atom is also present in carbon number 1. So we have to represent it in an alphabetical order according to the name of the substituent. So therefore the name of this one could be written as basically 1 bromo, then 2, 4, that is dinitro, and the overall name of this one is basically, it consists of benzene. So therefore the name of this would be 1 bromo 2, 4 dinitro benzene. So the name of this one is what we have indicated over here. And let us talk about the next one, that is this one. So it says that if one of the group that gives a special name to the compound and that is also present in the structure, then the special group is given the position number 1. So let me give you an example, and this is what we have did it earlier also, but let me give another example when it comes to that is more than 2 substituents. So suppose if this is the benzene that we have, and for which we have to give a 3 substituents. Suppose an example, like suppose this is the OH group that has been attached over here, and talking about the another group that is basically in this case it is nitro group, that is NO2, and again here it is suppose nitro group like NO2. So again the thing that we have to select is, we have to select in such a way that the least combination should be get, and in this case the special group or the special compound that has been obtained is nothing but phenol itself. So this is the phenol that we could get. So therefore this will be the carbon number 1, where the phenolic group or the OH group it has been attached over here. So therefore this is the carbon number 1, carbon number 2, 3, and 4, making this to be named as we could see, because this is the special group, special compound that we have got in terms of benzene and OH, that is nothing but phenol. So phenol would be basically the suffix of the name. So that is the reason that at carbon number 2 and carbon number 4 nitro groups are present. So therefore the name of this would be given as 2, 4 dinitro, and the special name is phenol. So this is how we could give the name for the compound. So these were the rules that we have studied for the monosubstituted, disubstituted, and for more than 2 substituted benzene, and this is how we have got to know what are the rules of the IUPAC nomenclature for them. And so thank you friends for watching this video. I hope you have understood this video very clearly, and we are going to do the separate lecture on the IUPAC name for the structures of the benzene derivatives. So we are going to do that also. So stay tuned for that, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.